Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is unit vectors. First, let us start with the definition of a unit vector. A unit vector is any vector that has a magnitude which is equal to 1. Magnitude is a word that means length of a vector. Am I right? So, any vector that has a length equal to 1 is called a unit vector. So how can we write it symbolically? It is written, it means magnitude of V. So if magnitude of V is equal to 1, then V is nothing but a unit vector. Are you clear with the definition of the unit vector? Okay. We have seen unit vectors in the vector algebra. There we saw that there are standard unit vectors called I, J, K. So technically we can say that I hat, it will be written in this way, I hat, J hat, K hat. For instance, this I hat is a vector of length 1 that heads into the right on a Cartesian plane. So it can be written as 1, 0. Okay. Now let us see how to calculate a unit vector. There is something like a formula there to calculate a unit vector. A unit vector calculation is accomplished by taking a non-zero vector and it can be divided by its magnitude. So I'll write the formula on the board. Here is the formula. Just like I hat as a unit vector, U hat is nothing but the symbolic representation of a unit vector. This arrow sign on the alphabet U indicates that it is a vector. So the hat sign above the letter indicates it is a unit vector. Hope you understand the difference between these two, vector and a unit vector. Okay, let us see how to calculate a unit vector using some examples. Here is the first example. We are supposed to find a unit vector in the direction of W, -4, 2. Okay, the first calculation here is to determine the magnitude of this one, because in the formula we have a magnitude also. So magnitude is nothing but its length. For that we could first sketch the vector on the graph sheet. W is -4, 2. -4 is the first coordinate, that is the x coordinate. So -4, 2. So this is how the sketch would look like. Am I right? Just plot the point and start from this origin and move towards the -4 first. And then start from the same point and go towards the 2. I mean 2 on the y-axis. So it should correspond to 2 on the y-axis. Hope you're clear with the sketch? Okay. The magnitude is nothing but the length of the vector. Or you can say that the hypotenuse. I'll just change the color to identify the hypotenuse easily. We have a right triangle and we need to find one side of the triangle. So obviously we can use Pythagoras theorem. Am I right? So using the Pythagorean theorem, we get this vector W is equal to square root of -4 the whole square plus 2 the whole square. So this would be equal to square root of 20. You can simplify the answer as much as possible. Therefore, the magnitude of W is 2 root 5. Now let's find the unit vector. Here is the formula for finding the unit vector. So here let us just plug in this value -4, 2 and this value is 2 root 5. You can also write it separately. So this is how it will look like. You can also use a calculator to get the decimal version of the answer. But it is always advisable to round the answer to the nearest 100. So this is how we calculate the unit vectors. Hope you're clear with this example. Okay, please note down the formula too. We know that unit vector is a vector which has a magnitude of 1. So for example, consider this vector V, 1, 3. This is not a unit vector. Do you agree with me? Okay, let me explain why. Because the magnitude of V is equal to square root of 10. This is not equal to 1. So the vector V cannot be a unit vector. This notation represents the norm or magnitude of a vector V. Okay, but let me show you one more vector. This vector is a unit vector because the magnitude of this vector W is square root of square both the numbers 1 over square root the whole square plus -1 over square root the whole square. So half plus half Square root of 1 is nothing but 1. Okay, so this is a unit vector and v is not a unit vector. Hope you understand the difference. The previous problem we saw is under some direction. Okay, the basic unit vectors I, j, which are of the length 1 and have directions along the positive x-axis and y-axis respectively. 1, 0, so it will be here, and 0, 1, it will be in the other direction. Okay, to find a unit vector with the same direction as a given vector, we divide by the magnitude of the vector, the formula we just saw. Okay, let me take one more example and explain you. Please read the question. What is a unit vector which has the same direction as r is equal to 2, -5? Okay, as usual, we first calculate the magnitude of the vector given. So magnitude of r here is, so this would be 4 plus 25, so square root of 29. According to the formula, we divide each component of r by the magnitude of r. So we have, so this is 2, -5. Okay, I'm going to write it separately. 2 over square root of 29, -5 over square root of 29. It is always advisable to write the answer with no square root in the denominator. Okay, so how to get rid of this? Multiply both numerator and denominator by square root of 29, just like rationalizing. So you'll get 2 square root of 29 over 29 and 5 times square root of 29 over 29. That's it for this example. Hope you're clear with this one. Okay, I'd like to take a question on describing the vector using the basic unit vectors I and j. Okay, here is the next example. Describe the vector v which is equal to 3, -2 using the basic unit vectors I and j. We generally use scalar multiplication because 3i is 3i and -2j. You have to use the numbers here. So in 2 dimension we write this in this way. So what would be the vector v? V is nothing but 3i minus 2j. Am I right? Let me take one example in 3 dimensions. Here is the next example. Write a vector v equal to 1, -3, 4 as a combination of the basic vectors I, j and k. What is a unit vector which has the same direction as v? Okay, in 3 dimensions we have I is nothing but 1, 0, 0 and j is 0, 1, 0. K is 0, 0, 1. Am I right? So each of these vectors is a unit vector pointing in a direction of a positive x, y and z axis respectively. Am I right? So as the previous example, here we are going to write this as 1 times I is nothing but I minus 3j plus 4k. We are supposed to find a unit vector with the same direction as v. So first we can calculate the magnitude of v. All are positive here. So magnitude of v is square root of 1 square plus square root of -3 the whole square plus 4 square under the same radical. So this is going to be 1, 9 and 16. So totally square root of 26. Now let's write the unit vector. Unit vector is either written as u hat or u suffix v. Whatever vector given in the question. So that should be written in the suffix place. You have to write everything separately and please make sure that you don't write the square root symbol in the denominator. So our final answer here is, I'm going to multiply both numerator and denominator by square root of 26 and write the answer in a simplified way. That's it for this problem. Hope you're clear with this one. You can also simplify it further. For this one you can write it as 2 over 13. Hope you're clear with this example. Unit vectors are generally helpful in finding the direction. And the elements of a basis are usually chosen to be unit vectors. And every vectors in the space may be written as a linear combination of unit vectors. And the most commonly encountered bases are Cartesian coordinates, polar coordinates and spherical coordinates. Each one uses different unit vectors according to their symmetry of the coordinate systems. So each one is different. The symmetry of the coordinate system is different. So according to that, they use different